Hi everyone, Assalamualaikum. In this video, we are going to continue with example 4 and the evaluating limits using squeezing theorem. Find limit x approaches 0, cosec 2x, tangent 3x. Alright, let's say we use direct substitution. Okay, using direct substitution from the given question here, we just plugging 0 into variable x here. And after we use direct substitution, no more limit expression. Okay, then we can write equals to cosec 2 times 0 tangent 3 times 0. Right? Then we have cosec 0 tangent 0. Right? From cosec 0 here, there is no cosec button on calculator. So what should we do? Alright, from reciprocal identity, okay, we have cosec x equals to 1 over sine x, right? So, we can write cosec 0 equals to 1 over sine 0 using this reciprocal function, right? And then times tangent 0, right? After that, we have tangent 0 over sine 0. And then using calculator, tangent 0 equals to 0 and sine 0 equals to 0. So we get the final answer equals to 0 over 0 if we use direct substitution. Okay, and remember 0 over 0 is indeterminate form. So this is error, right? So in this case, we cannot use direct substitution, but we need to use squeezing theorem because the given function here is trigonometric functions, right? As I said before, to solve this question, we need to use the squeezing theorem because the answer gives 0 over 0 when we use direct substitution. And when we use squeezing theorem, we need to refer the angle of trigo function, which is in terms of sine, right? So from here, we have the angle of this trigo function equals to 2x, right? So we need to refer squeezing theorem limit x approaches 0 sine 2x over 2x, which is equals to 1. And for the second trigo function, we have the angle 3x here, right? So we need to refer the squeezing theorem limit x approaches 0 sine 3x over 3x, which is equals to 1 under squeezing theorem, right? Alright, since we want to write in terms of sine from the squeezing theorem here, so from the given question, we can write limit x approaches 0 cosec 2x tangent 3x equals to limit x approaches 0. We write cosec 2x equals to 1 over sine 2x from reciprocal function identity. And we write tangent 3x equals to sine 3x over cos 3x, right? And in between is multiplication operation, right? Now, our goal is to use a squeezing theorem, which is given in terms of sine. In this case, we need to combine all terms containing sine in the same fraction. So, we just exchange 1 and sine 3x like this. Okay, we exchange 1 and sine 3x. Okay, so that we can combine sine function in the same fraction. Alright? Seriously? Are you sure we can simply exchange 1 and sine 3x just like that? Kenapa? Tak percaya? Look at this. Let's say if we have 1 over 5 times 3 over 2. The answer equals to 3 over 10. Okay, we multiply numerator and numerator and we multiply denominator and denominator. So we get this. Alright, how about if we have 3 over 5 times 1 over 2, right? We get the same answer, which is equals to 3 over 10, because we multiply numerator 3 and 1 here, and we multiply denominator 5 and 2 here. So we get the same answer. See, I told you. Right, from here, we just exchange numerator 1 and numerator 3. We get the same answer. Alright? So that's why in this case, we can simply exchange 1 and sine 3x so that we can combine all terms containing sine in the same fraction. Right? Got it? Alright, from here, we have multiplication of limits. So we can separate using the properties of limit. Limit x approaches a fx times gx equals to limit x to a fx times limit x to a gx. Okay, we separate the limit so we get two multiplication of limit. So from here, we can write like this. Okay, we have limit x approaches 0 sine 3x over sine 2x, and then times limit x approaches 0 1 over cos 3x. Alright, from here we have two multiplication of limit, so we can solve one by one. Okay, let's say we try to solve using direct substitution. Okay, from here, after we use direct substitution, we plug in 0 into variable x here, so we get sine 0 over sine 0, which is equals to 0 over 0. Right? And the other one, limit x approaches 0, 1 over cos 3x. If we use direct substitution, we plug in 0 into variable x here, so we get 1 over cos 0. And using calculator, cos 0 equals to 1. So we have equals to 1 over 1, which is equals to 1. This value is accepted because this is real number, but this is indeterminate form. So to solve this limit, we need to use squeezing theorem since we have three cofunctions here. But to solve this limit, we just use direct substitution. Right? Look at this. When we use squeezing theorem, the denominator must free from three cofunctions. But from here, we have denominator with three cofunctions. So, what should we do? From here, we need to multiply both numerator and denominator by 1 over x. Right? Why we need to multiply both numerator and denominator by the same expression? Because it means equals to 1. And remember, any value multiplied by 1 will not change the original value. Right? And then from here, we just use direct substitution to solve this limit. So we plug in 0 into variable x here. So we get 1 over cos 0. Right? And after that, when we solve this, we just multiply sine 3x times 1 over x. So we get sine 3x over x. And then we multiply sine 2x and 1 over x here. So we get sine 2x over x. Right? And then from here, we have division of limits. Okay? And then from here, after we solve cos 0, we get 1 here. So we get 1 over 1. Okay? And then any value multiplied by 1 equals to its original value. So we get limit x approaches 0, sine 3x over sine 2x over x. Okay? And from here, we have division of limit. So we can use the properties of limit. Limit x approaches a fx over gx equals to limit x approaches a fx over limit x approaches a gx. Okay? And when we use this theorem, we can write like this. Limit x approaches 0, sine 3x over x over limit x approaches 0 sine 2x over x. We split the division of limit, right? Right, from the previous slide, we got this. We have almost succeeded in approaching this theorem. Now, our goal is to write the denominator equals to the sine argument, right? So, from here, we multiply the first denominator here by 3, right? And at the same time, we need to multiply the numerator by the same value, right? To get the denominator exactly equals to the sine argument, right? And then, for the second denominator, we need to multiply by 2. And at the same time, we multiply numerator by the same value to get 1. Okay? We multiply by 2 here because we want to write denominator equals to the sine argument, right? And after that, we move out constant 3 from limit expression using the properties of limit. And same goes to constant 2 here. We move out from limit expression, right? After that, we get this. Okay, 3 limit x approaches 0 sine 3x over 3x over 2 limit x approaches 0 sine 2x over 2x, right? From here, now we have this theorem, limit x approaches 0 sine 3x over 3x, which is equals to 1. And then from here, limit x approaches 0, sine 2x over 2x equals to 1 from squeezing theorem, right? After that, we can replace limit x approaches 0, sine 3x over 3x equals to 1 using squeezing theorem. And we replace limit x approaches 0, sine 2x over 2x equals to 1 using squeezing theorem. Alright, so we get 3 times 1 over 2 times 1. And we simplify, so we get 3 over 2. This is the final answer. Right? Got it? Coming up next, evaluating limits using squeezing theorem, example 6. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.